Tamil Nadu 12th Standard Physics Book Back Multi-Choice Questions and Answers. Chapter 1 Electrostatics. Question number 1. Two identical point charges of a magnitude minus q are fixed as shown in the figure below. A third charge plus q is placed midway between the two charges at the point P. Suppose this charge plus q is displaced a small distance from the point P in the directions indicated by the arrows. In which all directions will plus q be stable with respect to the displacement? Option A, A1 and A2, B, B1 and B2, C, both directions, D, no stable. And the right answer for this question is option B, B1 and B2. Question number 2. Which charge configuration produces a uniform electric field? Option A, point charge, B, infinite uniform line charge, C, uniformly charged infinite plane, D, uniformly charged spherical shell. And the right answer is option C, uniformly charged infinite plane. Question number 3. What is the ratio of charges Q1 by Q2 for the following electric field line pattern? Option A, 1 by 5, B, 25 by 11, C, 5, D, 11 by 25. And the right answer for this question is option D, 11 by 25. Question number 4. An electric dipole is placed at an alignment angle of 30 degree with an electric field of 2 into 10 power 5 and c power minus 1. It experiences a torque Q equal to 8 Nm. The charge on the dipole, if the dipole length is 1 cm, is option A, 4 mc, B, 8 mc, C, 5 mc, D, 7 mc. And the right answer for this question is option B, 8 mc. Question number 5. 4 Gaussian surfaces are given below with charges inside each Gaussian surface. Rank the electric flux through each Gaussian surface in increasing order. Option A, D less than C less than B less than A, B, A less than B equal to C less than D, C, C less than A equal to B less than D, D, D greater than C greater than B greater than A. The right answer for this question is option A, D less than C less than B less than A. Question number 6. The total electric flux for the following closed surface which is kept inside water. Option A, 80 Q by epsilon naught, B, Q by 40 epsilon naught, C, Q by 80 epsilon naught, D, Q by 160 epsilon naught. And the right answer for this question is B, Q by 40 epsilon naught. Question number 7. Two identical conducting balls have positive charges Q1 and Q2 are separated by a center to center distance r. If they are made to touch each other and then separated to the same distance, the force between them will be option A, less than before, B, same as before, C, more than before, D, 0. And the right answer for this question is option C, more than before. Question number 8. Rank the electrostatic potential energies for the given system of charges in increasing order. Option A, 1 equal to 4 less than 2 less than 3. B, 2 equal to 4 less than 3 less than 1. C, 2 equal to 3 less than 1 less than 4. D, 3 less than 1 less than 2 less than 4. And the right answer for this question is option A, 1 equal to 4 less than 2 less than 3. Question number 9. An electric field exists in a certain region of space. Then the potential difference V equal to V0 minus VA, where V0 is the potential at the origin and VA is the potential at X, is equal to 2 meter is option A, 10J, B, minus 20J, C, plus 20J, D, minus 10J. And the right answer for this question is option C, plus 20J. Question number 10. A thin conducting spherical shell of radius r has a charge q which is uniformly distributed on its surface. The correct plot for electrostatic potential due to the spherical shell is... So there are various options of A, B, C and D. And the right answer is option B. Question number 11. 2 points A and B are maintained at a potential of 7 velocity and minus 4 velocity respectively. The work done in moving 50 electrons from A to B is option A, 8.80 into 10 power minus 17 joule, B, minus 8.80 into 10 power minus 17 joule, C, 4.40 into 10 power minus 17 joule, D, 5.80 into 10 power minus 17 joule. And the right answer for this question is option A, 8.80 into 10 power minus 17 joule. Question number 12. If voltage applied on a capacitor is increased from V to 2V, choose the correct conclusion. Option A, Q remains the same, C is doubled. B, Q is doubled, C is doubled. C remains the same, Q is doubled. D, both Q and C remain the same. And the right answer for this question is option C remains same, Q doubled. Question number 13. A parallel plate capacitor stores a charge Q at a voltage V. Suppose the area of the parallel plate capacitor and the distance between the planes are each doubled, then which is the quantity that will change? The answer for this question is option D, energy density only changed. Question number 14. 3 capacitors are connected in triangle as shown in the figure. The equivalent capacitance between the points A and C is option A, 1 mu f, B, 2 mu f, C, 3 mu f, D, 1 by 4 mu f. And the right answer for this question is option B, 2 mu f. Question number 15. 2 metallic spheres of radii 1 cm and 3 cm are given charges of minus 1 into 10 power minus 2c and 5 into 10 power minus 2c respectively. If these are connected by a conducting wire, the final charge on the bigger sphere is option A, 3 into 10 power minus 2c, B, 4 into 10 power minus 2c, C, 1 into 10 power minus 2c, D, 2 into 10 power minus 2c. And the right answer for this question is option A, 3 into 10 power minus 2c. Chapter 2, Current Electricity. Question number 16. The following graph shows current versus voltage values of some unknown conductor. What is the resistance of this conductor? Option A, 2 ohm, B, 4 ohm, C, 8 ohm, D, 1 ohm. And the right answer for this question is option A, 2 ohm. Question number 17. Wire of resistance 2 ohms per meter is bent to form a circle of radius 1 meter. The equivalent resistance between its two diametrical opposite points A and B as shown in the figure is option A, pi ohm, B. 5 by 2 ohm, C. 2 pi ohm, D. Pi by 4 ohm. The right answer is option A, pi ohm. Question number 18. A toaster operating at 240 volt has a resistance of 120 ohm. Its power is option A 400 watt, B 2 watt, C 480 watt, D 240 watt. And the right answer for this question is option C 480 watts. Question number 19. A carbon resistor of 47 plus or minus 4.7 k ohm to be marked with rings of different colors for its identification. The color code sequence will be option A, yellow, green, violet, gold, B, yellow, violet, orange, silver, C, violet, yellow, orange, silver, D, green, orange, violet, gold. The right answer is option B, yellow, violet, orange, silver. Question number 20. What is the value of resistance of the following resistor? Option A, 100 k ohm, B, 10 k ohm, C, 1 k ohm, D, 1000 k ohm. The right answer is option A, 100 k ohm. Question number 21. Two wires of A and B with circular cross section are made up of the same material with equal lengths. Suppose RA is equal to 3RB, then what is the ratio of radius of wire A to that of wire B? Option A 3, B root 3, C 1 by root 3, D 1 by 3. The right answer is option C 1 by root 3. Question number 22. A wire connected to a power supply of 230 volt has a power dissipation P1. Suppose the wire is cut into two equal pieces and connected parallel to the same power supply. In this case, power dissipation is P2. The ratio P2 by P1 is option A 1, B 2, C 3, D 4. The right answer for this question is option D 4. Question number 23. In India, electricity is supplied for domestic use at 220 volt. It is supplied at 110 volt in USA. If the resistance of 60 watt bulb for use in India is R, the resistance of 60 watt bulb for use in USA will be option A R, B 2R, C R by 4, D R by 2. And the right answer is option C R by 4. Question number 24. In a large building, there are 15 bulbs of 40 watts, 5 bulbs of 100 watts, 5 fans of 80 watts and 1 heater of 1 kW are connected. The voltage of electric mains is 220 voltage. The minimum capacity of the main fuse of the building will be option A 14A, B 8A, C 10A, D 12A. The right answer is option D 12A. Question number 25. There is a current of 1.0 A in the circuit shown below. What is the resistance of P? Option A 1.5 ohm, B 2.5 ohm, C 3.5 ohm, D 4.5 ohm. The right answer is option C 3.5 ohm. Question number 26. What is the current drawn out from the battery? And the image is given below. Option A 1A, B 2A, C 3A, D 4A. And the right answer is option A 1A. Question number 27. The temperature coefficient of resistance of a wire is 0.00125 per degree Celsius. At 300 K, its resistance is 1 ohm. The resistance of the wire will be 2 ohm at option A 1154 K, option B 1100 K, option C 1400 K, option D 1127 K. The right answer is option D 1127 K. Question number 28. The internal resistance of a 2.1 volt cell which gives a current of 0.2 A through a resistance of 10 ohm is option A 0.2 ohm, B 0.5 ohm, C 0.8 ohm, D 1.0 ohm. And the right answer for this question is option B 0.5 ohm. Question number 29. A piece of copper and another of germanium are cooled from room temperature to 80 K. The resistance of option A, each of them increases, B, each of them decreases, C, copper increases and germanium decreases, D, copper decreases and germanium increases. And the right answer is option D, copper decreases and germanium increases. Question number 30. In Joule's heating law, when R and T are constant, if the H is taken along the y-axis and I square taken along x-axis, the graph is option A, straight line, B, parabola, C, circle, D, ellipse. The right answer is option A, straight line. Chapter 3, Magnetism and Magnetic Effects of Electric Current. Question number 31. Magnetic field at the center O of the following current loop is option A, mu naught I by 4R cross product, B, mu naught I by 4R dot product, C, mu naught I by 2R cross product, D, mu naught I by 2R dot product. The right answer for this question is option A, mu naught I by 4R cross product. Question number 32. An electron moves in a straight line inside a charged parallel plate capacitor of uniform charge density sigma. The time taken by the electron to cross the parallel plate capacitor undeflected when the plates of the capacitor are kept under constant magnetic field of induction B vector is option A, epsilon naught ELB by sigma, B, epsilon naught LB by sigma L, C, epsilon naught LB by E sigma, D, epsilon naught LB by sigma. The right answer for this question is option D, epsilon naught LB by sigma. Question number 33. The force experienced by a particle having mass m and charge q accelerated to a potential difference v when it is kept under the perpendicular magnetic field B vector is option A, root of 2q cube BV by m, B, root of q cube B square V by 2m, C, root of 2q cube B square V by m, D, root of 2q cube BV by m cube. The right answer for this question is option C, root of 2q cube B square V by m. Question number 34. A circular coil of radius 5 cm and 50 turns carries a current of 3 ampere. The magnetic dipole moment of the coil is nearly option A, 1.0 ampere meter square, B, 1.2 ampere meter square, C, 0.5 ampere meter square, D, 0.8 ampere meter square. And the right answer for this question is option B, 1.2 ampere meter square. Question number 35. A thin insulated wire forms a plane spiral of n equal to 100 tight turns carrying a current I equal to 8 mA, that is milliampere. The radii of inside and outside turns are A equal to 50 mm and B equal to 100 mm respectively. The magnetic induction at the center of the spiral is option A, 5 mu T, B, 7 mu T, C, 8 mu T, D, 10 mu T. The right answer is option B, 7 mu T. Question number 36. 3 wires of equal lengths are bent in the form of loops. One of the loop is circle, another is semicircle, and the third one is square. They are placed in a uniform magnetic field and same electric current is passed through them. Which of the following loop configuration will experience greater torque? Option A, circle, B, semicircle, C, square, D, all of them. And the right answer is option A, circle. Question number 37. Two identical coils, each with n turns and radius r, are placed coaxially at the distance r as shown in the figure. If I is the current passing through the loops in the same direction, then the magnetic field at a point P, which is at exactly a distance r by 2 between two coils, is option A, 8n mu naught I by root 5 r, B, 8n mu naught I by 5 power 3 by 2 r, C, 8n mu naught I by 5 r, C, 4n mu naught I by root 5 r. The right answer is option B, 8n mu naught I by 5 3 by 2 r. Question number 38. A wire of length I carries a current I along the y direction and magnetic field is given by B vector equal to B by root 3 into I cap plus J cap plus K cap. The magnitude of Lorentz force acting on the wire is option A, root 2 by 3 B into I into L, B, root 1 by 3 B into I into L, C, root 2 B into I into L, D, root 1 by 3 B into I into L. The right answer is option A, root 2 by 3 B into I into L. Question number 39. A bar magnet of length L and magnetic moment M is bent in the form of an arc as shown in the figure. The new magnetic dipole moment will be option A, M, B, 3 by pi M, C, 2 by pi M, D, 1 by 2 M. And the right answer for this question is option B, 3 by pi M. Question number 40. A non-conducting charged ring carrying a charge of Q, mass M, and radius r is rotated about its axis with constant angular speed omega. Find the ratio of its magnetic moment with angular momentum. Option A, Q by M, B, 2Q by M, C, Q by 2M, D, Q by 4M. And the right answer is option C, Q by 2M. Question number 41. The BH curve for a ferromagnetic material is shown in the figure. The material is placed inside a long solenoid which contains 1000 turns per centimeter. The current that should be passed in the solenoid to demagnetize the ferromagnet completely is option A 1.00 mA, B 1.25 mA, C 1.50 mA, D 1.75 mA. And the right answer for this question is option C 1.50 mA. Question number 42. Two short bar magnets have magnetic moments 1.20 am square and 1.00 am square respectively. They are kept on a horizontal table parallel to each other with their north poles pointing towards south. They have a common magnetic equator and are separated by a distance of 20.0 centimeter. The value of the resultant horizontal magnetic induction at the midpoint O of the line joining their centers is, within brackets, horizontal components of the Earth's magnetic induction is 3.6 into 10 power minus 5 WB m power minus 2. Option A 3.60 into 10 power minus 5 WB m power minus 2. B 3.5 into 10 power minus 5 WB m power minus 2. C 2.56 into 10 power minus 4 WB m power minus 2. D 2.2 into 10 power minus 4 WB m power minus 2. The right answer for this question is option C 2.56 into 10 power minus 4 WB m power minus 2. Question number 43. A flat dielectric disc of radius r carries an excess charge on its surface. The surface charge density is sigma. The disc rotates about an axis perpendicular to its plane, passing through the center with angular velocity omega. Find the magnitude of the torque Q on the disc if it's placed in a uniform magnetic field whose strength is B, which is directed perpendicular to the axis of rotation. Option A 1 by 4 sigma omega pi Br. Option B 1 by 4 sigma omega pi Br square. Option C 1 by 4 sigma omega pi Br cube. Option D 1 by 4 sigma omega pi Br power 4. And the right answer for this question is option D 1 by 4 sigma omega pi Br power 4. Question number 44. A simple pendulum with charged bob is oscillating with the time period t and let theta be the angular displacement. If the uniform magnetic field is switched on in a direction perpendicular to the plane of oscillation, then option A, time period will decrease but theta will remain constant. Option B, time period remain constant but theta will decrease. Option C, both t and theta will remain the same. Option D, both t and theta will decrease. And the right answer for this question is option C, both t and theta will remain the same. Chapter 4, Electromagnetic Induction and Alternating Current. Question number 45. An electron moves on a straight line path xy as shown in the figure. The coil ABCD is adjacent to the path of the electron. What will be the direction of current, if any, induced in the coil? Option A, the current will reverse its direction as the electron goes past the coil. B, no current will be induced. C, ABCD. D, ADCB. The right answer is option A, the current will reverse its direction as electron goes past the coil. Question number 46. A thin semicircular conducting ring PQR of radius r is falling with its plane vertical in an horizontal magnetic field P, as shown in the figure. The potential difference developed across the ring when its speed V is Option A 0. Option B, B V pi R 2 by 2 and P is at higher potential. C, pi R BV and R is at higher potential. D, 2 R BV and R is at higher potential. The right answer is option D, 2 R BV and R is at higher potential. Question number 47. The flux linked with a coil at any instant t is given by pi b equal to 10t square minus 50t plus 250t. The induced EMF at t equal to 3s is option A minus 190V, B minus 10V, C 10V, D 190V. Right answer is option B minus 10V. Question number 48. When the current changes from plus 2A to minus 2A in 0.05 S, an EMF of 8 volt is induced in a coil. The coefficient of self-induction of the coil is option A 0.2 H, B 0.4 H, C 0.8 H, D 0.1 H. And the right answer is option D 0.1 H. Question number 49. The current I flowing in a coil varies with time as shown in the figure. The variation of induced EMF with time would be, so there are various options. The right answer is option A. Question number 50. A circular coil with a cross-sectional area of 4 cm square has 10 turns. It is placed at the center of long solenoid that has 15 turns per centimeter and a cross-sectional area of 10 cm square. The axis of the coil coincides with the axis of the solenoid. What is their mutual inductance? Option A 7.54 μH, B 8.54 μH, C 9.54 μH, D 10.54 μH. Right answer is option A 7.54 μH. Question number 51. In a transformer, the number of turns in the primary and the secondary are 410 and 1230 respectively. If the current in primary is 6A, then that in the secondary coil is option A 2A, B 18A, C 12A, D 1A. The right answer is option A 2A. Question number 52. A step-down transformer reduces the supply voltage from 220V to 11V and the increase in current from 6A to 100A. Then its efficiency is option A 1.2, B 0.83, C 0.12, D 0.9. And the right answer is option B 0.83. Question number 53. In an electrical circuit, R, L, C and AC voltage source are all connected in series. When L is removed from the circuit, the phase difference between the voltage and the current in the circuit is pi by 3. Instead, if C is removed from the circuit, the phase difference is again pi by 3. The power factor of the circuit is option A 1 by 2, B 1 by root 2, C 1, D root 3 by 2. And the right answer is option C 1. Question number 54. In a series RL circuit, the resistance and inductive reactance are same. The phase difference between the voltage and current in the circuit is option A pi by 4, B pi by 2, C pi by 6, D 0. And the right answer is option A pi by 4. Question number 55. In a series resonant RLC circuit, the voltage across 100 ohm resistor is 40 volt. The resonant frequency omega is 250 radius per second. If the value of C is 4 μF, then the voltage across L is option A 600 volts, B 4000 volts, C 400 volts, D 1 volt. And the right answer is option C 400 volts. Question number 56. An inductor 20 mH, a capacitor 50 μF and a resistor 40 ohm are connected in a series across a source of EMF V equal to 10 sin 340t. The power loss in AC circuit is option A 0.76 watt, B 0.89 watts, C 0.46 watts, D 0.67 watts. And the right answer is option C 0.46 watts. Question number 57. The instantaneous value of alternating current and voltage in a circuit are I equal to 1 by root 2 sine 100 pi Ta and V equal to 1 by root 2 sine 100 pi t plus pi by 3 V. The average power in watts consumed in the circuit is option A 1 by 4, B root 3 by 4, C 1 by 2, D 1 by 8. The right answer is option D 1 by 8. Question number 58. In an oscillating LC circuit, the maximum charge on the capacitor is Q. The charge on the capacitor when the energy is stored equally between the electric and magnetic fields is option A Q by 2, B Q by root 3, C Q by root 2, D Q. And the right answer is option C Q by root 2. Question number 59. 20 by pi square H inductor is connected to a capacitor of capacitance C. The value of C in order to impart maximum power at 50 Hz is option A 50 μF, B 0.5 μF, C 500 μF, D 5 μF. The right answer is option D 5 μF. Chapter 5 Electromagnetic Waves. Question number 60. The dimension of 1 by mu naught epsilon naught is option A L t power minus 1, B L square t power minus 2, C L power minus 1 t, D L power minus 2 t power minus 2. The right answer is option B L power 2 t power minus 2. Question number 61. If the amplitude of the magnetic field is 3 into 10 power minus 60, then amplitude of electric field for electromagnetic waves is option A 100 V m power minus 1, B 300 V m power minus 1, C 600 V m power minus 1, D 900 V m power minus 1. And the right answer is option D 900 V m power minus 1. Question number 62. Which of the following electromagnetic radiation is used for viewing objects through fog? Option A microwave, B gamma rays, C X-rays, D infrared. And the right answer is option D infrared. Question number 63. Which of the following are false for electromagnetic waves? Option A transverse, B non-mechanical waves, C longitudinal, D produced by accelerating charges. The right answer is option C longitudinal. Question number 64. Consider an oscillator which has charged particle and oscillates about its mean position with a frequency of 300 mHz. The wavelength of electromagnetic waves produced by this oscillator is option A 1 meter, B 10 meter, C 100 meter, D 1000 meter. The right answer is option A 1 meter. Question number 65. The electric and the magnetic field associated with an electromagnetic wave propagating along x-axis can be represented by option A E vector equal to E naught j cap and B vector equal to B naught k cap. Option B E vector equal to E naught k cap and B vector equal to B naught j cap. Option C E vector equal to E naught I cap and B vector equal to B naught j cap. Option D E vector equal to E naught j cap and B vector equal to B naught I cap. And the right answer for this question is option B E vector equal to E naught k cap and B vector equal to B naught j cap. Question number 66. In an electromagnetic wave, in free space, the RMS value of the electric field is 3 Vn power minus 1. The peak value of the magnetic field is option A 1.414 into 10 power minus 80, B 1.0 into 10 power minus 80, C 2.828 into 10 power minus 80, D 2.0 into 10 power minus 80. And the right answer is option A 1.414 into 10 power minus 80. Question number 67. During the propagation of electromagnetic waves in a medium, option A, electric energy density is double of the magnetic energy density. B, electric energy density is half of the magnetic energy density. C, electric energy density is equal to magnetic energy density. D, both electric and magnetic energy densities are zero. The right answer for this question is option C, electric energy density is equal to magnetic energy density. Question number 68. If the magnetic monopole exists, then which of the Maxwell's equation to be modified? Option A, integral over ed vector A vector equal to q enclosed by epsilon naught. B, integral over ed vector A vector equal to 0. C, integral over ed vector A vector equal to mu naught I enclosed plus mu naught epsilon naught d by dt integral ed vector A vector. Option D, integral over ed vector L vector equal to d by dt pi v. The right answer is option B, integral over ed vector A vector equal to 0. Question number 69. A radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred to the surface is option A, E by C, B, 2E by C, C, EC, D, E by C square. The right answer is option B, 2E by C. Question number 70. Which of the following is an electromagnetic wave? Option A, alpha rays, B, beta rays, C, gamma rays, D, all of them. The right answer is option C, gamma rays. Question number 71. Which one of them is used to produce a propagating electromagnetic wave? Option A, an accelerating charge, B, a charge moving at constant velocity, C, a stationary charge, D, an uncharged particle. The right answer is option A, an accelerating charge. Question number 72. Let E equal to E naught sine 10 power 6x minus omega t be the electric field of plane electromagnetic wave. The value of omega is option A, 0.3 into 10 power minus 14 rad s power minus 1, B, 3 into 10 power minus 14 rad s power minus 1, C, 0.3 into 10 power 14 rad s power minus 1, D, 3 into 10 power 14 rad s power minus 1. The right answer is option D, 3 into 10 power 14 rad s power minus 1. Question number 73. Which of the following is not true for electromagnetic waves? Option A, it transport energy, B, it transport momentum, C, it transport angular momentum, D, in vacuum, it travels with different speeds which depend on their frequency. The right answer is option B, in vacuum, it travels with different speeds which depends on their frequency. Question number 74. The electric and magnetic fields of electromagnetic wave are option A, in phase and perpendicular to each other, B, out of phase and not perpendicular to each other, C, in phase and not perpendicular to each other, D, out of phase and perpendicular to each other. The right answer is option A, in phase and perpendicular to each other. Chapter 6, Ray Optics. Question number 75. The speed of light in an isotropic medium depends on option A, its intensity, B, its wavelength, C, the nature of propagation, D, the motion of source WR to medium. The right answer is option B, its wavelength. Question number 76. A rod of length 10 cm lies along the principal axis of a concave mirror to focal length 10 cm in such a way that it ends closer to the pole is 20 cm away from the mirror. The length of the image is option A 2.5 cm, B 5 cm, C 10 cm, D 15 cm. The right answer is option B 5 cm. Question number 77. An object is placed in front of a convex mirror of focal length of f and the maximum and minimum distance of the object from the mirror such that the image formed is real and magnified. Option A 2f and c, B c and infinity, C f and o, D none of these. The right answer is option D, none of these. Question number 78. For light incident from air onto a slab of refractive index 2, maximum possible angle of refraction is option A 30 degree, B 45 degree, C 60 degree, D 90 degree. And the right answer for this question is option A 30 degree. Question number 79. If the velocity and wavelength of a light in air is VA and lambda A and in water is VW and lambda W, then the refractive index of water is option A VW by VA, B VA by VW, C lambda W by lambda A, D VA lambda A by VW lambda W. The right answer is option B, VA by VW. Question number 80. Stars twinkle due to option A, reflection, B, total internal reflection, C, refraction, D, polarization. The right answer is option C, refraction. Question number 81. When a bioconvex lens of glass having refractive index 1.47 is dipped in a liquid, it acts as a plain sheet of gas. This implies that the liquid must have refractive index. Option A, less than 1, B, less than that of glass, C, greater than that of glass, D, equal to that of glass. The right answer is option D, equal to that of glass. Question number 82. The radius of curvature of curved surface at a thin Plancke convex lens is 10 cm and the refractive index is 1.5. If the plane surface is silvered, then the focal length will be option A 5 cm, B 10 cm, C 15 cm, D 20 cm. The right answer is option B, 10 cm. Question number 83. An air bubble in glass slab of refractive index 1.5 near normal incidence is 5 cm. Deep when viewed from one surface and 3 cm deep when viewed from opposite face. The thickness of the slab is option A 8 cm, B 10 cm, C 12 cm, D 16 cm. The right answer is option C 12 cm. Question number 84. A ray of light travelling in a transparent medium of refractive index n falls on a surface separating the medium from air at an angle of incidence of 45 degree. The ray can undergo total internal reflection for the following n. Option A, n equal to 1.25, B, n equal to 1.33, C, n equal to 1.4, D, n equal to 1.5. The right answer is option D, n equal to 1.5. Chapter 7, Wave Optics. Question number 85. A plain glass is placed over various colored letters: violet, green, yellow, red. The letter which appears to be raised more is option A, red, B, yellow, C, green, D, violet. And the right answer for this question is option D, violet. Question number 86. 2-point white dots are 1 millimeter apart on a black paper. They are viewed by eye of pupil diameter 3 millimeters approximately. The maximum distance at which these dots can be resolved by the eye is, take wavelength of light, lambda equal to 500 nm. Option A, 1 meter, B, 5 meter, C, 3 meter, D, 6 meter. And the right answer is option B, 5 meter. Question number 87. In a Young's double slit experiment, the slit separation is doubled. To maintain the same fringe spacing on the screen to slit distance D must be changed to option A, 2D, B, D by 2, C, root 2D, D, D by root 2. And the right answer is option A, 2D. Question number 88. Two coherent monochromatic light beams of intensities I and 4I are superposed. The maximum and minimum possible intensities in the resulting beam are option A, 5I and I, B, 5I and 3I, C, 9I and I, D, 9I and 3I. The right answer is option C, 9I and I. Question number 89. When light is incident on soap film of thickness 5 into 10 power minus 5 centimeter, the wavelength of light reflected maximum in the visible region is 5320 ampere. Refractive index of the film will be option A, 1.22, B, 1.33, C, 1.51, D, 1.83. The right answer is option B, 1.33. Question number 90. First diffraction minimum due to single slit of width 1.0 into 10 power minus 5 centimeter is at 30 degree. The wavelength of light used is option A, 400 angstrom, B, 500 angstrom, C, 600 angstrom, D, 700 angstrom. And the right answer is option B, 500 angstrom. Question number 91. A ray of light strikes a glass plate at an angle 60 degree. If the reflected and refracted rays are perpendicular to each other, the refractive index of the glass is option A, root 3, B, 3 by 2, C, root 3 by 2, D, 2. The right answer is option A, root 3. Question number 92. One of the Young's double slits is covered with a glass plate as shown in the figure. The position of central maximum will option A, get shifted downwards, B, get shifted upwards, C, will remain the same, D, data insufficient to conclude. The right answer is option B, get shifted upwards. Question number 93. Light transmitted by Nicol prism is option A, partially polarized, B, unpolarized, C, plane polarized, D, elliptically polarized. The right answer is option C, plane polarized. Question number 94. The transverse nature of light is shown in option A, interference, B, diffraction, C, scattering, D, polarization. The right answer is option D, polarization. Chapter 8. Dual nature of radiation and matter. Question number 95. The wavelength lambda naught of an electron and lambda p of photon of same energy E are related by option A, lambda p into alpha into lambda E. B. Lambda P into alpha into root lambda E. Lambda P alpha 1 by root lambda E. D. Lambda P into alpha into root of lambda E square. The right answer is option D. Lambda P alpha root lambda E square. Question number 96. In an electron microscope, the electrons are accelerated by a voltage of 14 kV. If the voltage is changed to 224 kV, then the de Broglie wavelength associated with electrons would option A. Increase by 2 times, B. Decrease by 2 times, C. Decrease by 4 times, D. Increase by 4 times. The right answer is option C. Decrease by 4 times. Question number 97. The wavelength associated with the moving particle of mass 3 into 10 power minus 6 gram has the same wavelength as an electron moving with a velocity 6 into 10 power 6 ms power minus 1. The velocity of the particle is option A 1.82 into 10 power 18 ms power minus 1, B 9 into 10 power minus 2 ms power minus 1, C 3 into 10 power minus 31 ms power minus 1, D 1.82 into 10 power minus 15 ms power minus 1. The right answer is option D 1.82 into 10 power minus 15 ms power minus 1. Question number 98. When a metallic surface is illuminated with radiation of wavelength lambda, the stopping potential is V, and if the same surface is illuminated with a radiation of wavelength 2 lambda, the stopping potential is V by 4. The threshold wavelength for the metallic surface is option A 4 lambda, B 5 lambda, C 5 by 2 lambda, D 3 lambda. The right answer is option D 3 lambda. Question number 99. If a light of wavelength 330 nm is incident on a metal with a work function 3.55 eV, the electrons are emitted. The wavelength of the emitted electron is, within brackets, take h equal to 6.6 into 10 power minus 34 Js. Option A. Less than 2.75 into 10 power minus 9 m. B. 2.75 into 10 power minus 9 m. C. 2.5 into 10 power minus 12 m. D. Less than 2.5 into 10 power minus 10 m. The right answer is option B 2.75 into 10 power minus 9 m. Question number 100. A photoelectric surface is illuminated successively by monochromatic light of wavelength lambda and lambda by 2. If maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that in the first case, the work function at the surface of the material is option A hc by lambda, B 2 hc by lambda, C hc by 3 lambda, D hc by 2 lambda. The right answer is option D hc by 2 lambda. Question number 101. In photoelectric emission, the radiation whose frequency is 4 times threshold frequency of a certain metal is incident on a metal. Then the maximum possible velocity of the emitted electron will be option A root of hv0 by m, B root of 6 hv0 by m, C 2 into root of hv0 by m, D root of hv0 by 2m. The right answer is option B root of 6 hv0 by m. Question number 102. Two radiations with photon energies 0.9 eV and 3.3 eV respectively are falling on a metallic surface successively. If the work function of the metal is 0.6 eV, then the ratio of maximum speeds of emitted electrons will be option A 1:4, B 1:3, C 1:1, D 1:9. The right answer is option B 1:3. Question number 103. A light source of wavelength 520 nm emits 1.04 into 10 power 15 photons per second, while the second source of 460 nm produces 1.38 into 10 power 15 photons per second. Then the ratio of power of a second source of the first source is option A 1.00, B 1.02, C 1.5, D 0.98. The right answer is option C 1.5. Question number 104. If the mean wavelength of light from the sun is taken to be 550 nm and its mean power is 3.8 into 10 power 26 watts, then the average number of photons received by the human eye per second on the average from sunlight is of the order of option A 10 power 45, B 10 power 42, C 10 power 54, D 10 power 51. The right answer is option A 10 power 45. Question number 105. The threshold wavelength for a metal surface whose photoelectric work function is 3.313 eV is option A 4125 angstrom, B 3750 angstrom, C 6000 angstrom, D 20625 angstrom. The right answer is option B 3750 angstrom. Question number 106. A light of wavelength 500 nm is incident on a sensitive metal plate of photoelectric work function 1.235 eV. The kinetic energy of the photoelectrons emitted is B. Take H equal to 6.6 into 10 power minus 34 Js. Option A 0.58 eV, B 2.48 eV, C 1.24 eV, D 1.16 eV. And the right answer is option C 1.24 eV. Question number 107. Photons of wavelength lambda are incident on a metal. The most energetic electrons ejected from the metal are bent into a circular arc of radius r by a perpendicular magnetic field having a magnitude V. The work function of the metal is option A hc by lambda minus me plus e square b square r square by 2me. B hc by lambda plus 2me plus ebr by 2me the whole square. C hc by lambda minus mec square minus e square b square r square by 2me. D hc by lambda minus 2mc into EBR by 2MC the whole square. Right answer is option D. Hc by lambda minus 2me EBR by 2me the whole square. Question number 108. The work functions for metals A, B and C are 1.92 eV, 2.0 eV and 5.0 eV respectively. The metals which will emit photoelectrons for radiation of wavelength 4100 angstrom is option A only, B both A and B, C all of these, D none. And the right answer is option B both A and B. Question number 109. Emission of electrons by the absorption of heat energy is called dash emission. Option A photoelectric, B field, C thermionic, D secondary. The right answer is option C thermionic. Chapter 9. Atomic and Nuclear Physics. Question number 110. Suppose an alpha particle accelerated by the potential of V volt is allowed to collide with nucleus whose atomic number is Z, then the distance of closest approach of alpha particle to the nucleus is option A 14.4 Z by Va, B 14.4 Z by V angstrom, C 1.44 Z by V angstrom, D 1.44 V by Z angstrom. The right answer is option B 14.4 Z by V angstrom. Question number 111. In an hydrogen atom, the electron revolving in the fourth orbit has angular momentum is equal to option A H, B H by 4, C 4H by pi, D 2H by pi. The right answer is option D 2H by pi. Question number 112. Atomic number of H like atom with ionization potential 122.4 V for n equal to 1 is option A 1, B 2, C 3, D 4. The right answer is option C 3. Question number 113. The ratio between the first three orbits of hydrogen atom is option A 1:2:3, B 2:4:6, C 1:4:9, D 1:3:5. The right answer is option C 1:4:9. Question number 114. The charge of cathode rays particle is option A positive, B negative, C neutral, D not defined. The right answer is option B negative. Question number 115. In JJT Thomson E/M experiment, a beam of electron is replaced by that of muons, within brackets, particles with same charge as that of electrons but mass 208 times that of electrons. No deflection condition is achieved only if option A, B is increased by 208 times, B is decreased by 208 times, C, B is increased by 14.4 times, D, B is decreased by 14.4 times. The right answer is option C, B is increased by 14.4 times. Question number 116. The ratio of the wavelength radiation emitted for the transition from n equal to 2 to n equal to 1 in Ni++, He+, and H is option A 1:2:3, B 1:4:9, C 3:2:1, D 4:9:36. The right answer is option D 4:9:36. Question number 117. The electric potential between a proton and an electron is given by V equal to V0 in R by R0, where R0 is a constant. Assuming that both atom model is applicable to potential, then the variation of radius of nth orbit Rn with the principal quantum number n is option A Rn alpha 1 by n, B Rn alpha n, C Rn alpha 1 by n square, D Rn alpha n square. The right answer is option B Rn alpha n. Question number 118. If the nuclear radius of 27 Al is 3.6 Fermi, the approximate nuclear radius of 64 Cu is option A 2.4, B 1.2, C 4.8, D 3.2. The right answer is option C 4.8. Question number 119. The nucleus is approximately spherical in shape. Then the surface area of nucleus having a mass number A varies as option A power 2 by 3, B A power 4 by 3, C A power 1 by 3, D A power 5 by 3. The right answer is option A power 2 by 3. Question number 120. The mass of a 7 by 3 Li nucleus is 0.042 U, less than the sum of the masses of all its nucleons. The binding energy per nucleon of 7 by 3 Li nucleus is nearly option A 46 MeV, B 5.6 MeV, C 3.9 MeV, D 23 MeV. The right answer is option B 5.6 MeV. Question number 121. Mp denotes the mass of the proton and Mn denotes the mass of a neutron. A given nucleus of binding energy B contains Z protons and N neutrons. The mass M of n Z of the nucleus is given by where C is the speed of light. Option A M n Z is equal to N Mn plus Zmp minus Bc square. B M n Z equal to N Mn plus Zmp plus Bc square. Option C M n Z equal to N Mn plus Zmp minus B by C square. D M n Z equal to N Mn plus Zmp plus B by C square. The right answer is option C M n Z equal to N Mn plus ZMP minus B by C square. Question number 122. A radioactive nucleus, initial mass number A and atomic number Z, emits 2 alpha and 2 positrons. The ratio of number of neutrons to that of proton in the final nucleus will be option A minus Z minus 4 by Z minus 2, B, A minus Z minus 2 by Z minus 6, C, A minus Z minus 4 by Z minus 6, D, A minus Z minus 12 by Z minus 4. The right answer is option B, A minus Z minus 2 by Z minus 6. Question number 123. The half-life period of a radioactive element A is same as the mean lifetime of another radioactive element B. Initially, both have the same number of atoms. Then, option A and B have same decay rate initially. B, A and B decay at same rate always. C, B will decay faster rate than A. D, A will decay at a faster rate than B. The right answer is option C, B will decay at a faster rate than A. Question number 124. A radiative element has n0 number of nuclei at T equal to 0. The number of nuclei remaining after half of an half-life, that is at time T equal to 1 by 2 T1 by 2. Option A, n0 by 2, B, n0 by root 2, C, n0 by 4, D, n0 by 8. The right answer is option B, n0 by root 2. Chapter 10, Electronics and Communication. Question number 125. The barrier potential of silicon diode is approximately option A 0.7 V, 0.7 V, B 0.3 V, C 2.0 V, D 2.2 V. The right answer is option A 0.7 V. Question number 126. Doping a semiconductor results in option A, the decrease in mobile charge carries, B, change in chemical properties, C, the change in crystal structure, D, the breaking of covalent bond. The right answer is option C, the change in crystal structure. Question number 127. The variation of frequency of carrier wave with respect to an amplitude of the modulating signal is called option A, amplitude modulation, B, frequency modulation, C, phase modulation, D, pulse width modulation. The right answer is option B, frequency modulation. Question number 128. If a positive half wave rectified voltage is fed to a load resistor, for which part of a cycle there will be a current flow through the load? Option A, 0 degree to 90 degree, B, 90 degree to 180 degree, C, 0 degree to 180 degree, D, 0 degree to 360 degree. The right answer is option C, 0 degree to 180 degree. Question number 129. The primary use of Zener diode is option A, rectifier, B, amplifier, C, oscillator, D, voltage regulator. The right answer is option D, voltage regulator. Question number 130. The principle in which solar cells operates. Option A, diffusion, B, recombination, C, photovoltaic action, D, carrier flow. The right answer is option C, photovoltaic action. Question number 131. The light emitted in an LED is due to option A, recombination of charge carriers, B, reflection of light due to lens action, C, amplification of light falling at the junction, D, large current capacity. The right answer is option A, recombination of charge carriers. Question number 132. The frequency range of 3 MHz to 30 MHz is used for option A, ground wave propagation, B, space wave propagation, C, sky wave propagation, D, satellite communication. And the right answer for this question is option C, Sky wave propagation. Question number 133. To obtain sustained oscillation in an oscillator. Option A. Feedback should be positive. B. Feedback factor must be unity. C. Phase shift must be 0 or 2p. D. All the above. Right answer is option D. All the above. Question number 134. If the input to the NOT gate is A equal to 1011, its output is option A 0100, B 1000, C 1100, D 0011. The right answer is option A 0100. Question number 135. The electric series circuit in digital form is option A and B or C nor D NAND. The right answer is option A and. Question number 136. Which one of the following represents forward bias diode? In forward bias, P-type semiconductor is higher potential and N-type semiconductor is at lower potential. Option A, 0 greater than -2. B, -4 less than -3. C, -2 less than +2. D, -3 less than +5. Right answer is option A, 0 greater than -2. Question number 137. The given electrical network is equivalent to option A, AND gate, B, OR gate, C, NOR gate, D, NOT gate. The right answer is option C, NOR gate. Question number 138. The output of the following circuit is 1 when the input ABC is option A 101, B 100, C 110, D 10. The right answer is option A 101. Chapter 11. Recent development in physics. This is the last chapter. Question number 139. The particle size of ZNO material is 30 nm. Based on the dimension, it is classified as option A bulk material, B nanomaterial, C soft material, D magnetic material. The right answer is option B nanomaterial. Question number 140. Which one of the following is natural nanomaterial? Option A peacock feather, B peacock beak, C grain of sand, D skin of whale. Right answer is option A peacock feather. Question number 141. The blueprint for making ultra durable synthetic material is mimicked from option A lotus leaf, B morpho butterfly, C parrotfish, D peacock feather. The right answer is option C parrotfish. Question number 142. The method of making nanomaterial by assembling the atoms is called option A top-down approach, B bottom-up approach, C cross-down approach, D diagonal approach. The right answer is option B bottom-up approach. Question number 143. Sky wax is an application of nano product in the field of option A medicine, B textile, C sports, D automotive industry. The right answer is option C sports. Question number 144. The materials used in robotics are A aluminium and silver, B silver and gold, C copper and gold, D steel and aluminium. The right answer is option D steel and aluminium. Question number 145. The alloys used for muscle wires in robots are option A shape memory alloys, B gold copper alloys, C gold silver alloys, D two-dimensional alloys. Right answer is option A shape memory alloys. Question number 146. The technology used for stopping the brain from processing pain is option A precision medicine, B wireless brain sensor, C virtual reality, D radiology. The right answer is option C virtual reality. Question number 147. The particle which gives mass to protons and neutrons are Option A, Higgs particle. B, Einstein particle. C, nanoparticle. D, bulk particle. Right answer is option A, Higgs particle. Question number 148. The gravitational waves were theoretically proposed by option A, Konrad Röntgen. B, Marie Curie. C, Albert Einstein. D, Edward Purcell. The right answer is option C, Albert Einstein.
டே அண்ணா, ஏன் இப்ப மூஞ்சி தொங்க போட்டு வச்சிருக்க?
நான் பிகாம் முடிச்சுட்டு சிஏ அட்டென்ட் பண்ணலான்னு இருந்தேன். ஆனா இப்ப ஜாப் போனா அதெல்லாம் பண்ண முடியாதுல்ல. அப்படி இல்லைன்னா இண்டிவிஜுவலா சிஏ ப்ரிப்பேர் பண்ணலான்னு இருந்தேன். பட் ஆனா என் ஃப்ரெண்ட்ஸ் நிறைய பேர் இண்டிவிஜுவலா பண்ணி அட்டெம்ப்ட்ல இருக்காங்க. ஏதாவது இன்ஸ்டியூட்ல சேர்ந்து சிஏ படிக்கலாம்னா எந்த இன்ஸ்டியூட்ல சேர்ந்து படிக்கலாம்னு எனக்கு தெரியல.
அண்ணா, என்கிட்ட ஒரு நல்ல ஐடியா இருக்கு. எனக்கு தெரிஞ்சு இன்ஜினியரிங்கும் மெடிக்கல்ஸும் எனக்கு செட் ஆகாதோன்னு தோணுது. பேசாம சிஏ பண்ணலாமான்னு யோசிக்கிறேன்.
இந்த ஸ்மார்ட் கேப்போல இருந்து
லாஸ்ட் இயர் டிவி ப்ரோக்ராம் பார்த்தேன். அதுல ஒருத்தர் கெரியர் அட்வைஸ் கொடுத்தாரு. அதை கேட்டதுல இருந்து எனக்கு அதுவே மைண்ட்ல ஓடிட்டே இருக்கு.
சிஏ பண்ணதெல்லாம் அவ்வளவு ஈஸி கிடையாது. உங்களுக்கே ஒரு நியாயம் வேண்டாமா?
ப்ரோ அதெல்லாம் எனக்கு தெரியும். ஏன்னா நான் படிக்க போறது வந்து ஃபுல் டைம் ரெசிடென்ஷியல் ஆடிட்டிங் காலேஜ்ல. டிஸ்ட்ராக்ஷன் ஃப்ரீ என்விரான்மெண்ட், பெஸ்ட் டீச்சர்ஸ் கைடன்ஸ், நல்ல ஸ்டூடெண்ட்ஸ் கம்யூனிட்டியோட இருக்கிற காலேஜ்ல படிக்க போறேன்.
இப்படி ஒரு காலேஜ் இருக்கா என்ன?
ஈரோடு பக்கத்துல என்எம்சி ஆடிட்டிங் காலேஜ்னு ஒரு இன்ஸ்டிடியூட் இருக்கு. அங்க சிஏ அண்ட் சிஎம்ஏ கோச்சிங் கொடுத்துட்டு வராங்க. நீயும் சிஏ தானே படிக்கலாம்னு இருந்த. நம்ம 2 பேரும் என்எம்சிலயே அட்மிஷன் போட்டுடலாமா?
ஆமா, சூப்பர் ஐடியா. ஓகே, உடனே அப்பா அம்மாவை கூட்டிட்டு என்எம்சி காலேஜ் போயிடலாம்.
அட்மிஷன் போடலாம், சிஏ ஆகலாம்.
சூப்பர்.
எஸ்.